Eagle has landed.
Juliette, thank you very much for that. You're doing the directing and producing science and natural history Master of Arts at Britain's National Film and Television School, but you started training as a scientist. What changed?
Hi everyone. First of all, I'd like to thank the Royal Insitution of Australia for flying me over. It's really lovely to be here. So yeah, I did start training as a scientist and I worked in a lab. Actually, I did 2 years in different labs and I really enjoyed my time there. I loved working with the animals and everything, but I realized that what I liked the most was probably reading about other people's research and kind of putting it all together to make a story and then telling people about it. And also when I thought about doing a PhD, I never could really decide on one single topic that I'd like to explore for years. So that's why I decided to go into film, to just tell people about the science but not actually do it.
How hard were the slime molds to film? Did you have many failures or did you actually get a lot of footage you couldn't use, you just had to cut things out even though they were great?
No, it was difficult for sure. I think I used just about every shot that I shot in the film, just because slime molds they're predictable in some ways, so you can control certain factors, but they're also surprising because if you don't really think like the slime mold, like afterwards it seems really obvious why it did what it did. So one example was that there's also a maze experiment that they did in Japan. So I was supposed to reproduce that. So I had the model makers at the school redo the exact same maze and I put the slime mold inside the maze. So you cut it up in pieces and you put it in the maze and then it refuses and you've got food at the entrance of the maze and food at the exit. And so what's supposed to happen is that it forms a single vein in the shortest path, so it retracts from where there's no food. But when I looked at the result after filming, it was really strange because it had just like gone out of the maze outside in the petri dish, and I was like, why has it done that? I don't understand. So I had a little bit of a think, and then I realized that it had just formed a vein outside the maze, essentially. So it took the shortest path, but just because I didn't like block it, it just went outside the maze. So yeah, it was difficult. And there was another instance where the mold just stopped growing for a week, and I think it's because the temperature changed outside, or something in the humidity changed, so there was a whole panic, so I had to call a scientist and give me a super strain of slime mold that was really active, and then after that it worked. And I also moved the whole set to my bathroom, so it'd be really humid in there, and that seemed to do the trick. So the forest shots that you see were actually shot in a bathroom.
Le blob, is that the French word? Le blob? She uses le blob.
Yes, so she coined the term because it made her think of the film. I think it's with Steve McQueen. I've never seen it, but she calls it Le Blob, yes.
What were harder to direct, the slime molds, the scientists, or the voiceover artists? Is it harder?
Definitely the slime mold, because as I said, you have to kind of think like the slime mold, so you've got to, because they don't like a light. I don't know if that's not mentioned in the film. So I kind of had to place the lights in a way where I knew they were going to run away from the lights. So I had to put the camera in a way that I knew where the slime mold was going to go. So there was a whole operation thinking about that. So people were definitely easier.
Questions from the floor? Anyone?
I can repeat the question. So he's asked about the pulsing behavior. So yeah, it's right. That's right. The slime mold pulses. Because the way the liquid moves through the vein, it's explained a little bit, but it goes back and forth. So when it decides to go in a direction, there's always a stronger flow towards where it's going, but there's always a little reverse flow. So it goes back a little bit and then it goes forward, but that's why it pulses. I don't know if it serves a function, but that's why.
How does it know where the food is?
So I think it does have smell receptors, so it can smell some things, but in the case of the oat flakes, they can't really smell the oat flakes, so that's why they explore, and once they find it, they kind of put all the biomass where the food is. So it's a mixture of smelling it in some cases, and other cases just stumbling upon it.
I found some of the language
upfront a bit confusing it seems like they have, it's not just a simple division of a cell, it's two cells or more coming together, and then after that it becomes a multicellular cellular, or is it still a single cellular?
So it's a single cell. The sexual reproduction works where it's two different amoebae that fuse together, so they become one cell. But what's weird about it is that it has loads of nuclei. So it's one cell, but just a lot of nuclei. So it's very different to most things.
Do you have any idea how the sexual or union work? Obviously it's not like male-female.
So yeah, that's also really complicated. So in the case of Physarum polycephalum, the yellow one, because there's lots of different cymols, so there's all kinds of colours. There's white ones, orange ones, black ones. But in the case of that one, I think it's around 720 different sexes. So they've just got to find one that's different. So that's pretty likely, given the odds. But once they do, it fuses. So I don't know anything about the fusion in particular, but the nuclei fuse, sort of like in humans. And then they start dividing, and that's when you get loads of different nuclei.
This is not a very scientific question, but a couple. What was the budget for the film, and what will be the life of the film after it's finished with this tour? Or so where will it end up? Will it end up in schools, or universities, or what's?
So the budget of the film was around £800, so that's pretty cheap. But that's excluding the cost of cameras, because we get the hire through the school. And for the future life of the film, it's being entered into festivals right now, so there's a 2-year period where it can't be public, but then after that it'll go public so anyone can see it if they want to. It's going to a festival in Spain in September.
Where would you like it to end up after it's done the 2 years?
Just on the internet, I think, so anyone can watch it, but obviously in schools that would be really great, and anyone who wants to watch it should be able to, I think.
I've got a question about sound effects and colour grading. You put a sound effect in for when you sped up the footage. How hard was that, or why did you choose that particular sound effect? And was there any colour grading involved? These are filmmaking questions.
So for the sound effects, I had a wonderful sound designer, and I kind of gave him free rein, because at that point I'd seen the footage so many times I couldn't really be detached from it anymore. So he just went away and came up with ideas. And he used dried up fairy liquid to make that sound. He just kind of mushed it. But the idea behind the sound, I think, was because when you watch it silently, it looks strange, but the sound really brings it to life, I think, and it makes us connect with it more, because it's strange to see something moving and have no sound over it, because obviously it's eating and it's doing all these things. And I think what Ross, the sound designer, really wanted to do was also convey a sense of its thinking, even though it doesn't really think, but it's making decisions. So adding the sound kind of, I think, helps with that. And there was color grading involved, but that's what it looks like in real life. So it was just kind of adjusting the levels so it looked real.
Is the research looking just at this stage at what the slime does? Or is there some background to what use it might be, the research currently?
Yes, I haven't really touched on that on the film because it's only 10 minutes. But people have derived algorithms from the way that the slime behaves in those network experiments. So those can be used, for example, in peer-to-peer networking with mobile phones, because there's no central control, it's just individual phones communicating with each other. The same principles apply where you want lots of different routes in case one phone goes down, and you also want the most efficient path possible because you don't want to lose battery. So that's one example where it's used. But there's loads of different applications possible. Once you have the algorithms, you can just build that into anything, really. Oh, there's something else which I couldn't touch on in the film, but it's being used in biocomputing because you can run electrical currents through the slime mold. So they make this thing called a memory store, which is an electrical component that remembers the amount of current that goes through it, and basically the slime mold can do the same thing, so people are looking at using actual slime molds in electrical circuits. So that's something else. But I'm sure people will come up with loads of different uses. It's really a wonderful organism.
I wanted to ask Juliette about her ambitions as a filmmaker, what she thinks of Australia, where she's going to next, if she's met anyone amazing, what's her favourite slime mold. But if people want to ask her those questions up at the Settlers Arms, you were staying there, aren't you?
Yeah.
Okay, then please feel free to come back there. I think we might stop there and move on to the rest of the film program. But thank you very much, Juliette.
Eagle has landed.
But the status remains.
Now, it's looking good, over.